Professor Smita A. Takalkar as an assistant professor in ENTC department. Today we will learn C configuration. In a C configuration, we will learn there are the BJT, then symbol of BJT. It three terminal device. It is a semiconductor device and it's used for the amplify the electrical signal. In a previous sessions, we will learn the transistor configuration. In a transistor configuration, we will learn there are three transistor configurations. There are three transistor configuration and it is depends on one terminal. It is a common terminal and another is the input terminal, input device and an output device. We made a common to input and the output port. There are three possible configurations of the transistor. It is a common in a common base configuration. In the first configuration, common base configuration. In this configuration, the base terminal is common. That's why the input terminal is connected to the emitter terminal and output terminal is connected to the collector terminal. Then second, common emitter configuration. In a common emitter configuration, the common terminal is emitter and the input is connected to the base terminal and output is connected to the collector terminal. That's why it's naming as a common emitter. Common any ground is connected to the negative supply and that negative supply is connected to the ground. That's why negative supply, negative charge and the ground terminal we will short there. That's the meaning of the common. And last one, the third configuration, common collector configuration. In a common collector configuration, its collector terminal is common terminal and the input is connected through the emitter terminal. Input is connected to the base terminal and output will check in emitter terminal. This is three configuration. In your syllabus, only mentioning common emitter configuration because the common emitter configuration is a unity gain amplifier and its maximum amplification will be possible only common emitter configuration. But let's see in a transistor operation. This is already covered in a previous session. This is already covered in a previous sessions, but the prerequisite you have to explaining in a 10 to 15 minutes. Then after that directly start the C amplifier. The transistor operation in the active region NPN transistor. There are two junctions. One junction is the emitter base junction and another is the base collector junction. In the emitter to base junction, these junctions we can use for the input forward bias. Input forward bias. And the base to collector we can use output reversed bias. But here the junctions emitter terminal is a input, base terminal it is a common terminal and the collector terminal it's connecting a collector collecting all electrons. You can see the pink color arrow and the red color bubbles. In between there are pink color arrow is connected through the emitter and it's flowing through all electrons in a collector terminal. Go through them. It's moving to the collector terminal and some electrons it is a downwards. This downwards arrow means a base terminal. You can a terminal. This is a base terminal. some electrons is current flowing through the base terminal. Here orange color and in a white orange color arrow and white color bubble. This is the circle or the balls. You can use holes. In a yellow color, these all are the holes. This is the electrons. It is a N region and here P region. But the CB configuration in a common base configuration, it is, you can see the screen, maximum electrons is flowing NPN transistor. NPN transistor because electrons is creating a electrons is moving right side of the P region. Sorry. Electrons is moving right side of the P regions and combine with holes. This formation is known as the doping or the depletion region. And the depletion regions is possible the junction of emitter base junction. But maximum electrons is emits or its flow through the collector terminal. And here last N region, this is the third terminal, N region, here all electrons collected them. That's why here the in a emitter terminal, some current is flowing in a directional current I, because of the electrons is all moving in the collector terminal, and some holes is a chargeable holes is created in a P region, and after moving a holes with conduct is flowing the current in a negative charge through the holes and the positive charge through the electrons. That's why all electrons positive charge will be flowing through the collector terminal, and some holes it's moving through the emitter terminal. That's why here emitter terminal it is a open switch, because there are only few holes, and these few holes is created a negative charge that is not sufficient for the emitter terminal, because in a emitter terminal is a maximum electron, and because of that this emitter to base terminal, it is a open switch in a forward bias, and electrons it's moving or collecting in a collector terminal. This depletion region, it is possible in base to emitter junction, but here base to emitter junction, it is a base terminal is lightly doped and emitter terminal it is a heavily doped, because its diffusion process of emitter is very high and base terminal it is very less. But all electrons is moving through the collector terminal, and here some P regions, in a P region some electrons or the holes it's not chargeable, because of some electrons is all electrons is the negative direction in the circle, it is a negative direction. This negative direction, you can negative charge is created in a P region, and the emitter it is a positive charge in the junctions of base to emitter, it is a positive charge, and base to collector it is also positive charge. In a positive charge of emitter in N region and the base to collector junctions, it is also positive charge. That's why both the junctions it goes to reversed bias, because the transistor goes to saturation region. Transistor goes to saturation region. Here the minority carrier charge generated in holes, and here majority carrier charge generated in electrons. But the electrons is also After the junctions, electrons created a positive charge and some holes is created a negative charge. This negative charge is created in N region. That's why emitter terminal, it's a open switch and biasing is not possible through the base to collector terminal. That's why here collector current, it is a IC in a collector current is equal to injected collector current, because injected collector current is a flowing maximum electrons before the junction. Before the junctions, it is a collector current, and after the formation of junction, this collector current is directly proportional to the injected collector current, because here you can see directional convention current. This conventional current I is similar flowing through the base terminal. In the upper side, this is the base terminal, and this base terminal current P region is chargeable and the circuit is flowing in a emitter to base terminal in a input side. But it is a output side. In a output side, maximum electrons collected in collector terminal. That's why the collector terminal you can use for the output current is directly proportional to the input voltages. That's why here biasing is not possible. This is the meaning of the base leakage current with the open emitter. This open emitter is known as base emitter open leakage current. And you can find out the current amplification factor. The current amplification factor before junctions, it is a collector current IC, and after the junction, IC is equal to injected current. That injected current is a reverse saturation base to collector terminal, ICBO. That's why current amplification factor alpha DC is equal to IC collector current and after junction divided by ICBU, and this ICBU, it is a IC total collector current is equal to injected collector current plus ICBU, saturation of the collector base current, and alpha DC is equal to approximately 0.9, approximately 0.99. That is the current amplification factor of alpha DC. Current amplification factor alpha DC, it is a ratio. What is the ratio? It is a ratio of collector current, this equation, collector current divided by emitter current. But the emitter current, you can see emitter current is equal to in this equation, emitter current is equal to collector current plus base current, means input of the emitter is equal to base terminal in base terminal and the collector terminal. It is a sum of the collector and the base terminal. That's why here the configuration, you can see the configuration alpha DC is equal to IC divided by I, and it is approximately 0.99 less than 1. Then input characteristics of CB configuration. This also drawn if the input biasing is greater than, then the current of emitter is increases through the base to emitter terminal. After the transistor, it is a 0.7 volt. This is the 0.7 volt transistor is on. Required input voltage in a practically, this is practically you can perform the input characteristics and the output characteristics. The diode, its transistor, it's required 0.7 volt. If the input voltage is increases, VBE is increases, then the current is also increases. This is known as the input resistance of RI is a rate of change of, this is meaning of the delta. We can find out here the slope delta VBE divided by the input current IE. And here the extremely large electrons in known as the base width modulation in output side, because the whole all electrons is a junctioning with p region only. The p regions, it's a created negative charge, and the electrons is created collector terminal is in a collector terminal, n region is created negative charge. Some electrons, some holes is added with the collector terminal, but the one single holes will not be diffused in emitter terminal. That's why emitter terminal, it is a open switch in a total base width. If the width is increasing, that's why barrier potential voltage is increased in output base collector voltage. That's why VCB, this is the output voltage, VCB is directly proportional to the input voltage. If the current is increases, then voltage is according to, if the voltage is increases 0, this is the range of the 5, 0, 5, 10. You can write down 0, 1, 2, 3, 4, 5 up to 10 volt. This is the output emit base collector voltage. If the diode, sorry, the transistor, it's required input voltage 0.7 volt. This is the on state. Then here the blue line, it indicates the on line, and these regions is a reversed bias, because the output terminal VCE, the base of the junction, base to collector junctions, it's operate in reverse bias, and base to emitter junctions is operate in forward bias. That's why here the junction, it goes to reverse bias, transistor is on in a reverse bias. You can see the direction of the VE and the VCC. Supply is negative, here positive. If the supply is on, then the current is flowing through the collector terminal. Here the arrow, it indicates black arrow in the current, collector current, and the red arrow, it's a emitter current. And the resistor, transistor, it goes to reverse saturation, means both the transistor, first emitter terminal is open in a input side, but the output side, it is a open switch. That's why this is called to forward bias. Then both the junction goes to forward bias. This region is known as saturation region. And here third diagram, if the base to emitter junction in a increased voltage in a reversed bias, these regions base to emitter voltage, base to emitter voltage is increases in a forward bias, its conduction state, and the base to collector voltage, it is also increased in a reverse bias. That is known as active region. That is known as active region. Then you can see the slope. This is the slope in alpha DC. Then today's topic, CE configuration. You can see the CE configuration. Similar in a CE configuration, here the circuitry. What is the circuitry? Circuitry is connected to the CE, common emitter configuration. Here the emitter terminal is common in downwards. Then base terminal is connected to the holes, and here VBB, it is the biasing voltage across the base terminal. This is the resistance of RB, and here the resistance of RC. You can see the configuration of base to emitter, but diagram is similar, only this is diagram, the base terminal here, the diagram is this way. The base terminal is connected to the transistor. If the transistor, here the forward biasing, you can use for the NPN transistor. First, I am talking only input characteristic. if the input supply passing through the base terminal, the current is flowing through the resistor. Resistance is emits the current, and base terminal it is a less dope, then some current is flowing through the emitter terminal. The emitter terminal is connected to the negative side of the input, and the base terminal is connected to the positive side of the input. That's why here VBB, positive terminal connected to the resistor in a base terminal, and the negative terminal is connected to the emitter terminal. And here, if the current is flowing through the base in a junction of JC, you can find out the voltage emitter collector terminal. The output side, all the part is constant. Only I am talking about the input. The input resistance, if the voltage is increases, the current is flowing through the junction. In a P region, the junction formation in a P region, the P regions is created a negative charge, and the electrons it is created a positive charge in emitter terminal. That's why here the Ri is equal to delta VB, rate of change of input base resistance emitter, base emitter voltage. It is a ratio of rate of change of input base emitter voltage to the input bias current, base current, input bias. And here the biasing is possible. Here biasing is possible because the dynamic input resistance is very low. Very low means its value only 10 to 20 ohm, because base terminal it is lightly doped and the emitter terminal is heavily doped, but it is connected in a negative direction or the negative charge, and the base is connected to the positive charge in a input side. And then output side, the collector resistor, here the supply through the VCE, through the VCE. Here VCE is constant in a first input side. If the input voltage VBE is increases, still transistor is activation state after the 0.7. After 0.7, voltage is crossing the transistor its on state in a forward bias. In a forward bias, and we can use for the 10 volt, 20 volt, 30 volt. According to the input voltage increases, the current of IB, base resistor is also increases. The first part you can understand in a base terminal to emitter terminal in input side, if the transistor goes to forward bias, because the P regions is creating a negative charge, and N region through the emitter terminal is connected to the positive charge. And that's why input side of the base to emitter voltage, it's conduct in a forward bias. That's why in a forward bias, if VBE voltage is increases, the current is also increases. Students, you can understand in a CE configuration, you know CB configuration, common base configuration. Then after that, you can understand the CE configuration. Hello.
Yes, ma'am.
Yes,
ma'am,
ma'am.
C configuration repeat करा ना.
Yes, yes. Please repeat the question.
CE repeat करा ना मैं परत.
Okay. The C amplifier you can repeat. Okay. Here you can see in a red mark base IB. I is the current, B is the terminal of base. Where is put in circuit? Here the base IB. Then after that here the VBE, emitter base voltage. Where is the VBE in your circuit? Here the circuit of the VBE. Here emitter base voltage VBB, biasing of the base voltage, biasing, this is the biasing. Here IE emitter terminal. Only I am talking about the mark of the P region, junctions of emitter and the VBB. Biasing of input side. Not is talking about, I am not talking output side. Here VCE, because VCE is constant. First junction formation. Junction is formation only JE. JE, emitter base junction. And this emitter base junction, we can use these input characteristics. Okay, see here the supply is the positive point, or the positive supply is connected through the base terminal, and the negative supply is connected to the emitter terminal. Negative supply is connected here. This point, negative terminal is connected to the emitter terminal. Then here yellow color, it is a P region. In a yellow color, it is a P region, and it's a blue color, it's a N region. The N region, it is formation of electrons, and in a P region, it's a formation of holes. Holes, it is a positive charge, and electrons, it is a negative charge. And here the one line, for small line in between P and N region. In a P and N region, this is the depletion region. Depletion line of the junction, PN junction, emitter base junction. Then how it is possible? In a formation of junction, here the base terminal. Base terminal is connected through the resistor. Here holes is moving downwards of the electrons, or left side of the electrons, and electrons, this is the electrons. Holes, this is the current directions of the base terminal. Holes, in a P region, the holes is moving to the electrons, left side of the electrons, and electrons is moving right side of the holes, and combine moving electrons is moving right sides of the holes and combine with holes. N region electrons, N region मधले जे electrons आहे, electrons is moving right side of the P region and combine with holes, and the holes it's combine and create a positive charge in a hole region, and some holes is moving electrons combine with N region and created a positive charge. In a N region, it is created a positive charge, and P region, it is created a negative charge. This process is known as junction. If the junction is formed, then current is flowing through the circuitry. Then the current direction IB is equal to P. This is IB. Base resistor is connected to the P region, but the P region is a whole electrons combined with the electrons, and it is created a negative charge. And current is directions of the positive charge. This is the positive charge combined with negative charge. And here positive charge, negative charge. This negative charge connected to the holes. Here electrons is positive. created a positive charge, and the current is created the positive charge through the emitter terminal. That's why here conducting a current through the emitter terminal. If the transistor here P region मध्ये माझा P regions is operated in a negative charge and the N regions is operated a positive charge, that junction is known as forward biased junction, emitter based junction. It is a forward bias and current flowing through the circuitry. If the input voltage is increases, input voltage VBB is increases, that is the emitter base voltage is increasing, the current is also increases, because the resistance, this RB base resistance is very low. The base process, doping process of the base terminal, it is light, and the base resistance, this is also very low, means it is value for 10 ohm or the 20 ohm. Then maximum current is flowing through the emitter terminal, not a base terminal, because resistance is a current limiting control. Current limits for the base resistor, and it is also lightly doping process. That's why the maximum current is flowing in emitter terminal. This concept is known as transistor goes to forward bias, voltage is increases, then the current is also increases. Okay, right now you can understand.
Yes, ma'am.
Okay, then we will start the next part. VCE is constant. In the first part, input resistance Ri is a delta. Delta n is slope. Slope you can find out the base emitter voltage divided by the base current. It is a rate of change. It is a ratio of rate of change of emitter base voltage divided by input base current, and in a input base current is very low, it is a VCE. In the output side, collector emitter terminal is constant. This part is the constant. Then second part, in a output characteristic, this terminal is open. Which terminal? In a VCE, you can supply the current. Input side, in a input side, VCE is constant, but in output characteristics, this is the output characteristics, you can see the input current is the IB, emitter current IE, collector current IC, and its arrow, its collector current is flowing through the collector terminal, base current is flowing through the base terminal, and the emitter current is flowing through the emitter terminal. If in the input characteristics VBE is increases, then the current of input base resistors is increases. You know, in a previous diagram, if the voltage is increases in forward bias, then the current is also increases in forward bias. Then second part, this is the second part. If the VCC, the VBE, it is a forward bias, and VCE, collector emitter voltage, it's reversed bias. Reversed bias, because here negative terminal connected to emitter, and this negative terminal, it is also flowing the current in negative. The emitter terminal is goes to negative supply. Here in a positive side, emitter, it's a current negative terminal, and in a output side, current is supply negative terminal. But in a first diagram, this is also negative, that's why VCE is here constant. Output emitter collector voltage. It is a constant in a input characteristics, but the output characteristics, it is a open, and the current is flowing through the base terminal. Here the first circuit, first input side, input base current voltage is increased. Then the current is flowing through the circuitry through the base terminal. Some current is flowing in emitter current and some current is flowing through the collector current. And that's why transistor, it is a forward bias, it is a on switch. In a on switch, because base terminal doping process is very less, and it is a collector emitter terminal, transistor goes to off switch, because here supply is negative passing through the emitter terminal in a input side, and but the output side, this is also negative. Here the negative supply current is flowing through the collector terminal. Collector करना जो current है, it is a positive current for the supply. Then the transistor, some current is the base, hits the downwards, and then emitter goes to reverse the bias. VCE, it is a reverse bias. Then you can draw the VI characteristics. Output voltage VCE, output voltage VCE, emitter collector voltage. If the output voltage VCE, transistor, it is a on in a forward bias. If the input voltage VBE, input voltage VBE is 0.7 volt, input voltage VBE is 0.7 volt, the transistor, it goes on. This voltage is 0.7 volt, transistor, it's on in a forward bias, in a forward bias. Then the current is flowing through the IB, then the current is flowing through the IB, input input VBE, it's increase in a forward biasing, and then the output voltage VCE also increase, because the supply, another supply is connected to the output side. That's why maximum voltage is created in a collector current, because the BJT, this is BJT, bipolar junction transistor, it is a current control device. He can controlling the current in whole circuit. He can control the current whole circuit. That's why if the output voltage is increases as compared to the input side, output voltage is maximum, because the emitter terminal doping process is high in a base terminal. Base terminal, it is a light or very less doping process, and here the very high doping process through the emitter and the collector. That's why output collector current is increases, the input biasing current is also increases. It's known as the VBE is the 0.7 volt, input current is, then transistor it's on in a forward bias, then the current is flowing through the circuitry, and VCE, it is reverse the bias, then VCE, it is reverse bias, then the input current IB is a line, VCE is increases, then the collector current IC, it's also increases. And the 0.7 volt, this is required 0.7 volt. This 0.7 volt transistor 0 to 0.7, 0 to 0.669, 0.699 means 0.6 transistor, it's a cutoff region, because transistor is not on. Still 0.7 voltage is required. Then started the transistor, 0.7 volt is passing the circuit in the voltage VBE. So VBE is equal to 0.7 volt. Then the transistor is on and it's working in forward bias for input side. And still the output voltage 1, 2, 3, 4, 5, 6 up to 10 volt, 20 volt. That's why VCE goes to reverse bias and current is flowing through the collector terminal. If the output voltage is increases, then the current is also collector current. Output voltage VCE, emitter collector voltage is increases, then the collector current is also increases. And here the linearly graph, the active region, transistor, it goes to active region. Transistor, it is a forward bias, it is a on switch. Transistor, it is a reverse bias, it is a off switch. That's why transistor we can use in a C amplifier, transistor as a switch. Okay. And then last region, saturation region. This is the saturation region. The transistor, it is a current control device, and then the reversed bias, it is a reversed bias output side. Collector emitter voltage, it is a transistor, it goes for reversed bias, it is off switch, but the current is flowing. Transistor is off, but the current is flowing through the circuitry. That's why BJT can use for the current control device, and transistor collector current is goes to ICBO. ICBO, naming of the collector base saturation ICBO. That is meaning of the saturation region. Transistor goes to saturation in reverse bias. Here the slope, you can find out the VCE constant, here IC constant. If the CB configuration, we can find out the alpha DC, like a current amplification factor or current gain. Alpha DC is equal to collector current divided by emitter current, and beta DC we can find the beta DC is the collector current divided by base current. Because the emitter is the negative supply, he can gives to reverse bias, and the supply of the input, emitter terminal is the common ground, then input is connected to the base terminal and output is connected to the collector terminal in C configuration. And CB configuration, base terminal is connected to the ground and the emitter is connected to the input. That's why here the slope, it is the rate of change of collector current divided by the base current. You can see the beta DC equation. This is the beta DC equation, or the beta, we can find out the current factor. Which current factor? The current factor, current gain beta in a C configuration. You can write down alpha DC value, collector current divided by emitter current. Then what is the value of emitter? You can see the emitter is equal to collector current plus base current. Then collector and the base current, it is a total of the circuitry in a transistor emitter current, because emitter is heavily doped as compared to the base and the collector terminal. That's why maximum current is flowing through the emitter terminal, then collector terminal, and last one the base terminal. Then alpha DC, you can find out alpha DC is equal to IC divided by whole IC divided by, you can put the value of IE. What is the IE? IC plus IB. We can put here. Then the numerator and the denominator, you can divide it for the IB. Then IB is cancelled, and then the IC divided by IB. IC divided by IB, it is a beta DC. Then write down alpha DC is equal to beta DC divided by 1 plus beta DC. This is the value of alpha DC, current factor of alpha, and current factor of beta. Then write down the beta DC equation, IC divided by IB. IB is equal to IE is equal to IC plus IB. Then what is IB? Here write down IB is equal to EC minus of EI minus of IC. EI, IE, current of emitter minus of collector current. Then the collector current, you can put this value in the beta DC. Then numerator, denominator, you can divide I terminal. Current of I, then II is cancelled. Then IC divided by IE, it is a alpha DC. And beta DC, you can write down alpha DC divided by 1 minus alpha DC. This is the equation of alpha DC and the beta DC according to the current, because the BJT, it is a current control device. That's why here only alpha DC and the beta DC equation we can use here, the current only, current equation. And the alpha DC, it is a less than 1, because of it is a less than unity. Unity, it is a 1. Then comparison of alpha DC configurations like common base, common collector, common emitter. It is a first column, you can see the serial numbers like a 0, 1, 2, 3, 4. Then parameter, it's a properties. You can identify the input voltage, input current, input resistance is required, output resistance is required according to the configuration. There are 3 configurations: CB, common base configuration; CE, common emitter configuration; and CC, common collector configuration. What's the terminal? Common terminal. Write down the common terminal. Here the base is common. In a C, emitter is common, and here collector is common. Then between input and output, where the input and output, here the input common. Base is common, then input is emitter and the collector. Input is emitter, output is collector. Then E and C. Common is the emitter. Then input is base and the collector is output. Then last one, the collector terminal. You can see the collector. Collector is the common. Then the base is input and the emitter is output. Then next, conduction angle. This is most important. If the transistor is on, where is transistor is on? In a C amplifier, transistor is on and transistor it is also off. Transistor goes to forward bias in emitter base terminal. That's why it is working as a forward bias for 90 degree, and another emitter collector terminal in reverse bias output voltage. That's why the conduction angle of C amplifier, it's proper sinusoidal wave, 180 degree input, positive, negative half cycle. This is the cycle, 180 degree amplification angle for C amplifier, and other is the 0. That's why the transistor as a switch, we can use C amplifier only. Then input current, here the input current is IE, input current is the IB, and input current is also IB. Then output current is the collector terminal, collector current, output terminal collector, then collector terminal. And the C is the emitter. Then current again, it is very less. In a C configuration, less than 1 because of it's a 0.9 in alpha DC. In C amplifier, beta DC current amplification gain, it is very high because the input is base and the collector terminal. Here transistor as a on as well as off. That's why transistor we can use a switch. And here also I. Then the input voltage, output voltage. Write down the input voltage, base emitter voltage, base here, emitter base voltage, base emitter voltage, base collector voltage. You can read on first terminal, that terminal is the common, and then after that the voltage. Then output terminal, you can see the output voltage naming base to collector, collector emitter voltage, and the emitter collector voltage. Then last current gain alpha DC is very less than unity, means 0.9. Here the current gain, high current gain, because beta DC is equal to 99. Here alpha DC is equal to beta DC divided by 1 plus beta DC. Then what is the alpha DC? Alpha DC is less than unity. This is known as the 0.99, and this value you can substitute in beta DC. Beta DC 0.99 divided by 1 is 0.99. That is the 99 is the value of beta DC, and it is a higher gain. And last, here the input and output resistance is the value you can use for the very low resistance in the input side. It is also low resistance, 1 kilo ohm, 1 into 10 raised to 3. This is the value of the emitter resistance, and here 500 kilo ohm. That's very high resistance in the input side. But the transistor we required input side is, what is meaning of transistor? The transistor is called as transfer the low input resistance to the high output resistance. This concept is only C amplifier. That's why transistor we can use as a switch in C amplifier, common emitter configuration only. Okay. Okay. Then next lecture we will continue for the biasing. Thank you all. Any doubt or any questions regarding the C amplifier, you can ask me. Hello, students. Hello.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.